Hello again, students. In this video, we're going to be working on some more complicated examples involving negative exponents and reciprocals. Let's get started. Okay, let's get started with our first example. Here it's asking us to simplify 4 to the negative half. To do that, I'm going to apply my little three-step process. My first step is to write the 4 to the negative half as 4 to the half. I'm removing the negative exponents here. The next thing I'm going to do is I'm going to find the reciprocal of this number. Well, to do that, I just imagine having a fraction and bringing it to the other side. So I'm going to have 1 on the top and 4 halves on the bottom. All right. So now I'm on step 3, which is evaluate. Well, I don't really know how to evaluate an exponent like this, a fractional exponent. So I'm going to convert it to a radical. And the radical I'm going to be using is a square root, because a number to the half is the same as the root of a second root, and our variable is going to be x to the 1 here. So what we're going to see is I'm going to have 1 over the square root of 4. And evaluating that, I get 1 over 2. And that's my final answer. Okay, I'm now looking at a very similar example where I have a base of 4 raised to a negative exponent. The first thing I'm going to keep in mind is I'm going to remove the negative, and then next I'm going to be taking the reciprocal of that number. Well, this is going to leave me with 2 times 1 over 4 to the 0.5. And that 0.5 is kind of bothering me a little bit. Well, it turns out, if I remember converting decimals to fractions, that 0.5 is equal to a half. Well, that's nice, because now I can write this as 2 times 1 over 4 to the half. And I can simplify this further, just like in my last example, by writing 4 to the half as the square root of 4. And I also see that I can multiply the top numbers. Okay, the reason that works is that 2 is technically 2 over 1. All right, so I'm going to have 2 as my numerator and the square root of 4 as my denominator. Simplifying that, I get 2 over 2. And the answer to that is obviously 1. All right, here's another example. In this example, I have a negative exponent as a numerator to a fraction with a number as a whole number as the denominator. So my trick here is I do want to get rid of the negative, and I do want to take the reciprocal. But we do have a nice little trick to do all of that, and that's by simply moving this term to the bottom, to the other side specifically. So the answer to this is going to be 1, because we're moving the 2 to the 3 to the bottom. That's going to leave us with 3, let's just keep that there, times 2/3. We brought the 2/3 term to the bottom and also removed the negative exponent. All right, that actually completed step 1 and 2, and what is going to happen is now I can just evaluate. Well, I'm going to have 1 over 3 times, well, 2 to the 3 is 2 times 2 times 2. 2 times 2 is 4, times another 2 is going to be 8. So 2 to the 3 is 8. And so I'm going to have 1 on the top and 24 as the denominator. And this is my final answer. Okay, here's a very similar example to example 3. Instead, the exponent, the negative exponent, is in the denominator. So, in applying my trick, I'm going to bring this 3 cubed to the top. Well, that is going to accomplish 2 times 3 cubed. Technically, it's all over 1, but I don't need to write that. So I'm going to keep it that way. And I just need to figure out what 3 cubed is in my evaluation step. Well, 3 cubed is 3 times 3 times 3. And the first 3 times 3 is 9. And then 9 times 3 is going to get me 27. So this is 27, which means I'm doing 2 times 27. And you can simply put this in a calculator or do the multiplication inside, but the answer to this is 54. Okay, in this example, I see lots of negatives. However, only one of the negatives is a negative exponent. This is simply a negative on the outside of the base. So I won't be able to apply my exponent rules for negative exponents to this term, but I can definitely do it to this term. To do that, I'm going to imagine that this is all over the number 1, and I'm going to be able to bring this to the other side. That is going to accomplish the negative 2 squared on the top and the 3 over 4 on the bottom. Or sorry, 3 to the 4 on the bottom. And so I'm evaluating now negative 2 squared. Well, the negative is not in the base, it's on the outside of the base. The difference is negative 2 squared is not equal to negative 2 in a bracket all squared. Okay? These would get us different results. This one would be negative 4, which we're going to use here, and this one would be positive 4. So we're going to see that I have negative 4 on the top, and in the denominator, I have 3 to the 4. Well, 3 to the 4 is the same thing as 3 cubed times 3, and I know that 3 cubed in my last example was equal to 27, and so I'm doing 27 times 3, and in evaluating that, I'm going to have 81. And so my denominator is 81. Okay, here's an example that's algebraic. Well, what I'm going to do is I'm going to imagine this is all over 1, and I'm able to move the negative exponent to the bottom. And so what this is going to equal to is y squared stays in the numerator, and the denominator is just going to be x to the 3. And we're all done. Okay, here's our final example. And in this one, I have two algebraic terms that are being raised to a negative exponent. And so this isn't actually too bad. All I'm going to do is imagine this is all over 1, and I'm going to be able to bring each term to the other side. It's starting out in the numerator, and it's going to end up in the denominator. So what this is going to get is we're going to have 1 on the top in the numerator, and we're going to have m squared times n cubed in the denominator. And that's it. I hope you found these examples helpful, and I'll see you in the next video where we work on more of these exponent laws. Until then, take care and stay safe. Bye!